Hello, this is Blake McBride, and today I'm going to be demonstrating my results for the final project in CS 598 Deep Learning for Healthcare at UIUC. For my project, I attempted to reproduce the results from the paper Anti-Cancer Drug Synergy Prediction in Understudied Tissues Using Transfer Learning by Kim et al. In 2020. In this paper, Kim et al. Present a deep learning model that's capable of predicting the synergies between various kinds of drugs in order to aid in cancer research. And this addresses a significant challenge faced by the drug discovery domain because the data for particular types of cancers and tissues currently is unevenly distributed. And so this transfer learning approach is really the core innovation of this study, and it's a technique where a model developed for one task is reused as a starting point for a model on a different task. And in this case, it involves transferring the insights gained from the drug-cell interactions in common cancers to then improve synergy predictions in the less common ones. So the data used to power this model comes from 4 different sources, the first being DrugComb for drug synergy and sensitivity data, and then for genomic features, the authors use a combination of DrugBank, TTD, and Link. The biggest issues I faced in my reproduction attempt were absences and misalignments in the data. Although the authors used publicly available datasets for their original findings, these datasets have since updated to the point of no longer being compatible with the author's code. Even after requesting access to the original data from the authors directly, I was only able to get some and not all of it, which forced me to reverse engineer some of the original data that had been used and synthesize it with the new updated data. But I still believe that there are misalignments which cause some downstream errors in the training process and causes some of my metrics to be different from those presented in the original paper. I show my results in Table 1 for drug response prediction accuracy for the data-rich tissues, and for combination synergy on this task, my model actually outperformed the results of the original paper, but for monotherapy sensitivity, although the AUC was fairly consistent, the NDCG was significantly lower. I had similar findings in the second experiment, which was drug response prediction accuracy for understudied tissues, in this case bone and prostate cancer. For combination synergy in the prostate, my model again outperforms the original results, but for the bone across monotherapy sensitivity and combination synergy, these were both much lower than in the original paper, which I think speaks to those misalignments and absences in the original data that the authors used. The final experiments revolved around ranking the predicted synergistic drug combinations from the model and determining which of those combinations were actually synergistic in nature. For prostate, my results actually outperformed those reported in the original paper by identifying 10 out of the 20 top predicted combinations as actually being synergistic, or a 50% hit rate. And then for the bone, again, it's slightly higher at identifying 6 out of the 20 top rankings as a 30% hit rate, compared with the original paper, which presented a 25% hit, or 5 out of the 20 true synergistic drug combinations. To close things off with a brief discussion, I recount here the issues I faced in my reproduction attempt, and I don't believe the paper is reproducible in its current state given the lack of documentation and the unavailability of the original data, and to this end I make the recommendation for reproducibility future considerations that it would be in the best interest of both the authors and future researchers for the authors to publicly share all of the original data used. This concludes the video presentation, and I have all the references shown up on screen. You can refer to this file in the GitHub repository for more comprehensive details and instructions on anything from environment setup to data downloading and pre-processing steps to model training and evaluation, as well as the discussion and results tables that have been included here. I also highly recommend you check out the original work by Kim et al. It's a great read. Thanks so much for watching, and have a great rest of your day.